Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. A'udzubillahi minasyaitanirrajim. Bismillahirrahmanirrahim. Alhamdulillah. Again, we are given the opportunity to discuss one subtopic in mathematics form 6. So today we are going to discuss how we apply the product rule in mathematics problem. So before that, let's say we are given y equal to fx multiplied with gx. Then we differentiate both sides of this equation with respect to x. Given us the left hand side will be equal to dy dx. And on the right hand side, it is a product of fx with the first derivative of gx plus with the product of gx and first derivative of x. So dy dx equal to fx multiplied with the first derivative of gx plus with gx multiplied with the first derivative of x is known as a product rule. So let me take a look at this question, where the question is given that y equal to e raised to the power of negative mx multiplied with cosine px, show that second derivative of y with respect to x plus 2m multiplied with dy dx plus in the bracket of m squared plus p squared multiplied with y equal to 0. So before we solve this equation, let we recall a few rules in the differentiation which involving exponential and trigonometry. So when we differentiate e raised to the power of x with respect to x, given us the first derivative, the multiplication of the first derivative of fx and e raised to the power of fx. When we differentiate cosine of fx with respect to x, given us the multiplication of first derivative of fx with negative sine fx. When we differentiate sine fx with respect to x, given us the first derivative of fx multiplied with cosine fx. So now let me solve this problem. So let we differentiate the equation given both sides with respect to x. This will give us dy dx on the left hand side, and on the right hand side, by applying the product rule, given us the first is let we do our assumption. E raised to the power of negative mx is our fx and cosine px is our gx. So therefore, it given us on the right hand side e to the power of negative mx multiplied with the differentiation of cosine px is given us negative p sine px plus with cos px. Then we differentiate e to the power of negative mx with respect to x, given us negative m e raised to the power of negative mx. How we get this answer? Because when we differentiate e to the power raised to the power of negative mx with respect to x, it will given us, when we differentiate the power negative mx with respect to x, we will have negative m. Then we multiply this with e raised to the power of negative mx, given us negative m e raised to the power of negative mx. So by observing the second term, which is we simplify the second term, given us, we rearrange the order, we put a constant in front. So we have negative m e raised to the power of negative mx multiply with cos px. So we know that based on the problem given, y is equal to e negative mx cos px. Therefore, the second term will equal to negative my. Therefore, dy dx, then we expand, we simplify the product of the first term given us negative p e raised to the power of negative mx multiply with sine px plus with, in the bracket, negative my. So negative plus in the bracket negative my just now when we simplify given us negative my. We differentiate this equation both sides with respect to x. Given us the left hand side is equal to the second derivative of y with respect to x. So for the first term in the dy dx here, we have two terms. So the first term I put it in the oval, with the side is color blue color, and this is the second term. So meaning that we have two terms. So we need to apply a product rule. So let negative p e raised to the power of emx is our fx. Then we differentiate the second term with respect to x, given us p cos px plus with sine px. Then we differentiate the term in the blue oval, the ring, the blue rings oval, which is negative pe to the power of negative mx. We differentiate this term with respect to x, given as mpe raised to the power of negative mx. Why? Because when we differentiate the power of exponential with respect to x, so we will have negative m. Negative m will multiply with the negative p, given us the positive mp. Then we multiply with e raised to the power of negative mx. Then we take away m dy dx. Since m is a constant, y is our variable, then we differentiate y with respect to x, given us dy dx. So then we take away m dy dx. Okay, for the first term here, we have negative pe raised to the power of negative mx multiply with p cosine px. By simplify these two terms, the product of these two terms is equal to negative p square e raised to the power of negative mx cosine px plus with, then we simplify the second term given us, we put constant on the front of the variable, given us mp multiply with e raised to the power of negative mx multiply with sine px, and we take away m dy dx. So then for the first term on the right hand side, when we observe e to the power of negative mx cos px is actually equal to y. For the second term, or for the term for the pe raised to the power of negative mx sine px in the second term, it is actually equal to something that we can find it from our previous solution, which is, on the previous solution we find out that dy dx is equal to negative pe raised to the power of negative mx multiply with sine px plus with negative my. By at both sides of the equation with pe raised to the power of negative mx sine px given us the left hand side equal to pe raised to the power of negative mx multiplied with sine px. Then we take away dy dx on both sides of the equation, given us the answer. It is left hand side equal to take away dy dx and take away my on the right hand side. Therefore, we substitute this result into this term, which I put in the blue ring square, where blue ring square pe raised to the power negative mx sine px is equal to negative dy dx take away my. So therefore, we simplify this equation. So we have second derivative of y with respect to x is equal to negative p square y plus with m in the bracket negative dy tx take away my and take away m dy dx. So therefore, by expansion, this expression of d2y dx2, which is second derivative of y with respect to x, equal to negative p square y plus m in the bracket negative dy dx minus my, take away m dy dx, given us the second derivative of y with respect to x is equal to negative p square y take away m dy dx, take away m square y, and take away m dy dx. So second derivative of y with respect to x, what we need to do now is we add both sides of equation with p square y. We add both sides of equation with m dy dx, and then we add both sides of equation with m square y, and then we add again both sides of equation with m dy dx, given us it is equal to 0 on the right hand side of the equation. So therefore, second derivative of y with respect to x is equal to, when we observe this equation, let me take a look here. We have m dy dx on the third term on the left hand side, and we also have the same term on the fifth term on the left hand side. So we can regroup the same term here. So m dy dx plus m dy dx is equal to positive 2m dy dx. So let me observe the second term on the left hand side and the fourth term on the left hand side. They have a common factor, where the common factor is a positive y. So we take out a positive y first, and then we put in the bracket p square plus m square. So therefore, the second derivative of y with respect to x plus 2m dy dx plus in the bracket p square plus m square multiplied with y equal to 0. Since the additions is obey commutative law, where commutative law said that p square plus m square is equal to m square plus p square. Therefore, we successfully proved that second derivative of y with respect to x plus 2m first derivative of y with respect to x plus in the bracket m square plus p square multiply with y equal to 0. Masya Allah, tabarakallah, alhamdulillah, Allahumma salli ala Muhammad. So we complete our solution here. Okay, until we meet again.